Hello, and welcome to a tutorial video for CSCI 2824, Discrete Structures. Today, we'll be covering probability, learning to calculate likelihood. Before we do so, we need to go over a few terms that we'll use in terms of probability. The first one is an experiment. An experiment is a procedure with multiple outcomes. The second term we need to know is sample space. And the sample space is a set of all outcomes. And finally, we need to know an event. And an event is a subset of all outcomes. So now that we have these terms in mind, we'll start to use them a little bit to solve some probability problems. Our first one is a basic probability problem. We're asked, what is the probability that when 2 dice are rolled, the sum is 7? And so the first thing we want to note here is a pretty basic rule of probability. The probability of an event E happening is number of ways that E can happen over our total number in the sample space, which you might also see written as E over S. So keeping that in mind, let's go about solving this problem. The first thing we want to find is what is our sample space? So how many ways are there to roll 2 dice? And essentially, we know that there are 6 ways to roll the first die, and there are 6 ways to roll the second die. So this will give us 36 possible ways to roll the 2 die. And now we want to find what are the number of ways that we can add up to 7. That is our event. We can roll a 1 and a 6. We can roll a 2 and a 5. We can roll a 3 and a 4. We can roll a 4 and a 3. We can roll a 5 and a 2. And we can roll a 6 and a 1. So those are the total number of ways to add up to 7 with 2 die. So again, let's note that this 36 is our S value. And these total number of ways are our E value. So we count that we have 1, 2, 3, 4, 5, 6 events in our subset. This means that the probability of the sum being 7 is equal to 6 over 36, which is equal to 1/6. Great. Let's go into another probability problem. And this problem has to do with complements. Sorry about that. So we want to suppose we're given the following problem. A sequence of 10 bits is randomly generated. What is the probability at least one bit is a 1? So the first note we want to make here is that the sum of all events is always equal to 1 in probability. It wouldn't make sense if we had the sum of all events being, say, 2, because then that would mean that there's a 200% chance that something would happen, and that's not likely. The second note is that the probability that an event doesn't happen is equal to 1 minus the probability that the event happens. So this is our complement, and we're going to use it to our advantage here. So we're trying to find the probability that at least one bit is 1. So that means that 1 or more bits is a 1. So that is equal to the probability that 1 bit is a 1, plus the probability that 2 bits are 1s, plus the probability that all 10 bits are 1s. So finding the probability for all of these terms could get to be pretty challenging. And so instead, we use our complement rule. So really, the probability that we have one or more bits that are 1 is equal to 1 minus the probability that the event doesn't happen, which is the probability that none of the bits are 1. This is much easier. We only need to solve for one term. So the probability that 0 bits are 1 means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 bits, and for each one we have a 0. And there's a 1/2 chance of getting a 0 for all 10 of these options, which means that the probability of none of the bits being 1 is 1/2 to the 10th, meaning that the probability that 1 or more bits is a 1 is equal to 1 minus 1/2 to the 10th. So there's a pretty good likelihood there. Now let's go over a third type of probability problem that you'll see. And this is when you have to deal with unequal probabilities. So suppose a die is biased so that 3 appears twice as often as all other outcomes, which have an equal probability. What is the probability of rolling an odd number on this die? So first, let's form an equation for this problem. We know that the total probability, so the probability of rolling a 1, plus the probability of rolling a 2, plus the probability of rolling a 3, plus the probability of rolling a 4, the probability of rolling a 5, and the probability of rolling a 6 must add up to 1. And now we can break that down a little bit further. We know that 3 appears twice as likely as all other outcomes, but all of the other outcomes have an equal probability. So this means that P1 equals P2 equals P4 equals P5 equals P6. And because a 3 is twice as likely as all other outcomes, we can say that P3 equals 2 P1. And now that we've broken it down, we want to bring it back up. And so we can rewrite this equation as P1 plus P1, so we're substituting in P1 for P2, plus 2P1, here we substitute in 2P1 for P3, plus P1, plus P1, plus P1 equals 1. So this means that we have 1, 2, 3, 4, 5, 6, 7 P1s. So we now have 7 P1 equals 1, or P1 equals 1/7. Great. Now we can use this to find the probability that we roll an odd number. So our odd numbers are 1, 3, and 5. We know that the probability of rolling a 1 equals 1/7. And because P1 equals P5, we know the probability of rolling a 5 equals 1/7. Finally, we know the probability of rolling a 3 is 2 times P1. So P3 equals 2/7. And thus, our total probability of rolling an odd is P1 plus P5 plus P3, or 4/7. Probability is a really fun and important subject to learn. I hope you enjoyed this video, and good luck.